boys and girls, this is Mrs. Wenger-Vossio, and today we're going to be covering a brand new chapter. It's 2.1, Rational Numbers. Don't forget our heading for our notes. You have to have the lesson number and the title and today's date. And also, as a reminder, don't forget to always highlight the lesson number and the title of the lesson. Let's go ahead and begin. So we're going to start off with some key ideas. The first key idea we're going to talk about is what a rational number is. So here I have the definition of a rational number. It says, a rational number is a number that can be written as A over B, where A and B are integers. In other words, A and B can be any numbers that are integers, any positive or negative whole numbers, but it cannot be 0 for B. So I would like for you to copy this down. Remember, you are to copy down everything from the notes that you see in the video. Also, along with that, I would like for you to copy down this chart right here, this table, or this diagram. So as you're copying it down, I'm going to go ahead and go over this. It's talking about what a rational number is. Notice that we have this rectangle, and everything in this rectangle is a rational number. So a rational number is an integer. A rational number is a whole number. So it's just broken down into pieces. So on the outside, if you notice, rational numbers are in decimal forms or fractions, because we will learn in this chapter that a fraction can be written as a decimal, and a decimal can be written as a fraction. Now, going back to this, a rational number, remember, is when you have A over B. That looks like a fraction. This is a fraction. This is a fraction. This is not a fraction, but we will learn we can put this as a fraction. Now, integers, they don't look like A over B or in that form, but can you put negative 10 over 1? Absolutely. So because of that, integers are also considered rational numbers. You have a negative or a positive. Now, you can also say just whole numbers, positive numbers, are also rational numbers. So go ahead and copy this down. We'll be talking a lot about rational numbers in this chapter and what they are. So here's a quick summary of what I just discussed above. Now, if you forget anything I just said, or it just didn't make sense in the above, here's what you really need to know about what a rational number is. Ready? A rational number are basically just fractions. If somebody asks you what are rational numbers, you would say it's a fraction. If you have a number, you can make it a fraction, it's a rational number. If you see a fraction, it's a rational number. So all rational numbers, I repeat, are fractions. All right, with that idea, we're going to go ahead and move on to the next key term. We're going to talk about decimals. Now, as I mentioned, decimals are also rational numbers, because we will learn that we can take decimals and put them into fractions in our examples. So I have here, it says terminating decimals. What are they? We have a terminating decimal is a decimal that ends. That means if you have a GPA of 3.65, this decimal ends at the 5. This is going to be the hundredths place. So it doesn't go on. It just stops. So this is called a terminating decimal. Now we'll learn later on in our examples that we can take this decimal and we can make it as a fraction. Okay, now a repeating decimal. What a repeating decimal is that when you have, let's say, a decimal that has a pattern that repeats. So let's pick a pattern that repeats. I'm going to say 5, 5, 5, 5. So if you notice what keeps on repeating, the 5. Since the 5 keeps on repeating, we use what is called a repeating bar. So we put a bar on top. Notice I didn't put it on the 6. I just put it on the 5 because the 5 is what repeats. So if I wrote the answer as a 3.65 with a bar, I know that this means 3.65555. Okay, if I went too fast in this slide or any of the previous slides, feel free to pause it, press replay, and jot down what you need. All right, now we're going to talk about our first example. So here are the two fractions I was mentioning. Now, a fraction, I repeat, is a rational number. So we are staring at a rational number here and a rational number here. And what they're asking us to do now is to change these fractions or rational numbers into a decimal. So to do that, this first example, we have what is called a mixed number. Why is it called a mixed number? Because we have a whole number and a fraction. Now, to change it to a decimal, we have to take the whole number and convert this fraction into an improper fraction. So we'll go 2 times 4, which is 8, plus 1, which would be 9. So now what I'm going to do is I'm going to put 9 on top. And we did this before in our previous grade, so this is just a review. 9. And what I'm going to use is the same denominator they use here, so 4. Now I notice there's a negative out here, so I'm going to put a negative. And what I'm going to do to this problem is I'm going to divide it. So to change this into a decimal, I'm going to go top goes in, bottom goes out. So first number 9 goes in, 4 goes out. And then I'm going to go ahead and divide it. 4 goes into 9 once. So I'm sorry, twice. And then we're going to do 4 times 2 is 8. And 9 minus 8 is 1. Since I don't have a number here, I'm going to drop a decimal, add a 0. We have 0 here, and then 4 into 10. And don't forget my decimal here. It's going to be 2 again. It's still 8. 10 minus 8 is 2. Drop down another 0 since I don't have a number, so for my placeholder. 4 times what is 25? So I would put 5 here. And it looks like my number ends right there. So my answer will be 2.25. But don't forget, that we do have a negative right here. So we're going to have to make sure that we add a negative into our answer. So our answer is going to be negative 2.25. Again, if there's something that didn't make sense to you in this example, feel free to press pause and replay it again. Okay, in our next example, we have here 5 over 11. So what we're going to do is we're going to go ahead and do top goes in and bottom goes out. So for this one, we're going to do 11 into 5. We can't do that, so I'm going to drop a decimal, add a 0. And we have 11 goes into 50. Yes, how many times? Well, I know 11 times 4 is 44. So I'm going to do 44 here. And then I'm going to do 50 minus 44 is going to be 6. So 11 can't go into 6, so I drop a 0. And I know that 11 goes into 60. Closest is 5 times. So I'm going to go ahead and put 11 times 5 is 55. Again, this is just long division we've done. 60 minus 55 is going to be 5. And then it keeps on going. So we'll keep on going. 0 here. Drop down the 0 down here. Now, 11 goes into 50 about 4 times, because 11 times 4 is 44, closest. 11 times 5 would be 55, and that's too much. Now, if you notice, it's going to repeat. What looks like it's going to repeat? Let's do one more. 11 to 60, about how many times? 5. So it looks like the 4 and the 5 keeps on repeating. So what I'm going to do is I'm going to stop right there. And remember in our key ideas in the last page, if you see a pattern that repeats, I see 4 and 5 keeps repeating. We're going to go ahead and put a bar on top of the 4 and the 5. So that tells you that 5 over 11 as a decimal is 0.45. Let me just redo that again, 0.45. So there is our answer, 0.45. Okay, so this is changing a fraction into a decimal, and all we did was divide. And are these two fractions a rational number? Yes, a rational number is a fraction. All right, now on a separate sheet of paper, don't forget you do your homework on a separate sheet of paper and notes only in your notebook. So for this, I would like for you to try example or problems 1, 2, 3, and 4 on a separate sheet of paper. And if you have any questions, please ask them tomorrow in class. All right, example 2. Now that we know how to take a fraction and change it into a decimal, we're now going to do the opposite. We're going to take the decimal now and change it into a fraction, but in simplest form, meaning it's going to be the smallest fraction we can come up with. So to do that, you need to know your place values. I hope many of you guys remember your place values. Now, if you don't, I do have a chart for us to refer back to for this example. I will be talking about this chart tomorrow in class. So here is our chart for the place values. Do you notice anything after the decimal right here? This is the tens, hundreds, thousands, 10,000s, and hundreds. We'll probably be working with this the most in this chapter. So let's go ahead and focus on that. Okay, so if you notice, we have the number 0.26. 0.26 happens to land right here, just like this example, 0.23, but 0.26. So what you do is you look at your last number, and you ask yourself, what place value is this last number in? So if I look at my chart, 1, 2, 1, 2, the 6 should be right here, so it looks like it's in the hundreds. So since it's in the hundreds, what I do is I will put for my denominator at the bottom 100, and all I do is use the top number, 26, as it is, and put a negative, since it has a negative. Now this is my fraction. I just converted it into fractions. The only problem is that I did not reduce it. So what I'm going to have to do is reduce this 26 over 100 into simplest form. And then after I do that, that would be my final answer. So when we do that, we're going to get 26. What can we divide that by? We can divide this by 2. And so since we divide this by 2, the top will be negative 13 over, and the bottom half of 100 will be 50. So this would be my final answer for this decimal. So if I say negative 13 over 50, is it the same as this? Your answer should be Yes, it's the same as negative 0.26. Okay, all right. I would like for you now to try some on your own. Continue this on the same paper as you were doing your other on your own, 1, 2, 3, 4, do 5, 6, 7, 8. Again, this goes on that same on your own paper. Do not put this in your notebooks. Okay, example 3. Again, I hope you are copying down everything you see from this video, including the examples. You do not have to write down the question, but just answer the question with me. So it says here, the table below shows the elevations of 4 sea creatures, how low they are below the sea. And which of these sea creatures are deeper than the whale? Explain. So here we have the whale, so we'll look at the whale. And we want to know between the 3 that we have left, 1, 2, 3, which one is going to be the deepest? So to do that, what we need to do to compare them is we need to change them all to decimals. Now we already learned that in our example, so what we're going to do is we're just going to divide 13 into 10. So top goes in, bottom goes out. Okay, so, and then after we divide 13 into 10, you'll get negative 1.3. Then we're going to take this one. Before we divide it, we have to convert it, change it into an improper. 2 times 5 plus 1. So 2 times 5 is going to be 10, plus 1 is 11 over 5 negative. And then after that, we're going to go ahead and do our division. So we're going to do top goes in, bottom goes out. And then when we do that, we will get a total of negative 2.2. And then for this one, top goes in, bottom goes out. And we will get a total of negative 0.18. I just forgot the negative right here. I'll put, oops, sorry. No, it's just negative right there, because this is a negative right here. Don't forget, these are negatives. Okay, and now I noticed for this one that when I did solve it, I will get a repeating pattern of 1818. So don't forget that. Now, this really quick, I did not finish this, but I'm just going to go ahead and do the first step of this. 10 goes into 13 one time, so that's 10. And then 3, drop a decimal, add a 0, and then you would just finish the rest. And that's how I got 1.3 negative. And the same thing with this one. You would do 5 goes into 11 2 times, and then 5 times 2 is 10. 11 minus 10 is 1. Drop a decimal, add a 0. 5 into 10 is going to be 2. So that's how I got negative 2.2. And the same thing goes for this one. So now I'm going to look at all the decimals or fractions I just converted, here, and here, and here. We're going to see that negative 2.2 and negative 1.3 is going to be less than negative 0.8. So these two would be this answer here, anglerfish and the squid. Anglerfish and the squid would be the one that is deeper than the whale, because this one is just at a negative 0.1, so it's actually going to be not deep, it's higher. So the answer would be anglerfish and squid are deeper. So what if, using the same idea information, it says, what if for on your own, number 9, the elevation of a dolphin is negative 110 kilometers? Which of the sea creatures in example 3 are deeper than the dolphin? So the dolphin's negative 1 over 10. Which one is deeper than the dolphin? So first, don't forget you have to change this into a decimal. Then you can figure out if example 3 are deeper than the dolphins. Which of the example problems in example 3 are deeper than the dolphin? Okay? All right. I would like for you to try this exit ticket. One is to convert this fraction to decimal. The other one is to convert the decimal into a fraction. Now, if you have any questions from today's video, feel free to ask them tomorrow, and then we'll talk about all the notes in our videos today. All right, as a reminder, don't forget to have your video notes, the on your own completed, and the exit completed on the same page as on your own. And we will talk about this tomorrow. Have a great day. Bye-bye.